Yesterday we learned the acronym SOHCAHTOA. SOHCAHTOA stood for sine of theta equals the opposite over the hypotenuse. Ka stood for cosine of theta equals adjacent over hypotenuse. And toa stood for tangent of theta equals opposite over adjacent. Today we're going to use those trig ratios to describe the triangle ABC. First, we need to solve for the missing side of triangle ABC. If we look, we know two sides of the right triangle. To figure out the third side, we're going to use the Pythagorean theorem. 4 squared plus question mark squared equals 6 squared. Now we just need to solve for question mark. Subtract 16 from both sides. Take the square root of both sides of the equation. So question mark equals the square root of 20. But we need to simplify the square root of 20. 20 is divisible by 4, and 4 is a perfect square. So I'm going to rewrite 20 as 4 times 5. And the square root of 4 is 2, and I'm left with 2 square roots of 5. So now I know all three sides of the right triangle. I'm going to look at the 6 trig ratios in triangle ABC. If we look, we have angle A, which is right by point A, creates the angle A, and angle B. Angle A is going to have 3 trig ratios associated with it, sine, cosine, tangent. And angle B is going to have 3 trig ratios, sine, cosine, tangent. Let's start with A. Let's look at the sine of angle A. Sine is opposite over hypotenuse, and we find our right triangle 6 is our hypotenuse. And if we look at angle A, opposite of angle A is 2 square roots of 5, and the hypotenuse is 6. Now I need to simplify this fraction. I can divide this 2 and this 6 and simplify down to the square root of 5 over 3. So the sine of angle A equals the square root of 5 over 3. If we look at the cosine of angle A, cosine is adjacent over hypotenuse. Adjacent to angle A is side 4. So the cosine of A is going to be 4 over 6, which simplifies down to 2/3. So the cosine of A is 2/3. And the last trig ratio, tangent. Tangent is opposite over adjacent. Opposite of angle A is 2 square roots of 5, and adjacent to angle A is 4. And again, we can simplify this fraction. This 2 and this 4 can be simplified down to the square root of 5 over 2. So the tangent of A is the square root of 5 over 2. So around vertex A, I have 3 trig ratios. Now when I switch to angle B, B is my other acute angle in my right triangle. Sine is still opposite over hypotenuse, but when I switch to angle B, opposite of angle B is side 4. So my ratio becomes 4 over 6, which simplifies down to 2/3. So the sine of angle B is 2/3. The cosine of angle B. Cosine is adjacent over hypotenuse, and adjacent to angle B is 2 square roots of 5, and the hypotenuse is 6. Simplify that fraction, I end up with the square root of 5 over 3. So the cosine of B is the square root of 5 over 3. And the last trig ratio, tangent. Tangent is opposite over adjacent. Opposite of angle B is 4, and adjacent to angle B is 2 square roots of 5. I can simplify this 4 and this 2 and end up with 2 over the square root of 5. And I can never have a square root in my denominator, so I need to rationalize that denominator by multiplying the top and the bottom by the square root of 5. The square root of 5 over the square root of 5 is 1, so I really haven't changed my equality, I'm just multiplying by 1. I end up with 2 square roots of 5 over the square root of 5 times the square root of 5, which is just 5. So the tangent of B is 2 square roots of 5 over 5. So these are my 6 trig ratios in triangle ABC. When I switch angles, my opposite and my adjacent sides switch, my hypotenuse stays the same, and I just need to simplify my ratios, simplify my fractions.